So this is a lab. Okay.
Yeah.
Can you hear me at the back? Cool. All right. So Jumpstart on Spring Cloud. So Jumpstart because I was Jumpstarting myself. So so you know about me. I've been introduced. And what we will cover is a bit of the foundation of Spring Cloud and service discovery and a bit of inter-service communication. So we will do what we can, and what we could do later is like I can review this talk in more depth, but it's just to have the concept and engage interest on Spring Cloud. By the way, who has already used Spring Cloud in professional context? No one? Okay. So you can help me. All right. So I'm going to go through that. So basically, what I'm saying there is that from monolithic to loosely couple microservices. So what we want is actually go to ever less couple architecture. So now the tendency is like moving from microservice to a serverless architecture. So I wonder what's going to happen next, but this is where we're going. The business driver. So basically, when we talk about microservice architecture, so we're talking about an organization that wants several teams to cooperate on different simple services that can communicate as well amongst each other. So that would mean that those services would know how to communicate between each other, but also that the whole application is able to scale and is resilient to failure. So why Spring Cloud? That's where we start. So I'm saying there the microservice pattern. I guess it's more like kind of the characteristic of microservices. So as I was saying before, so resilience. So what do we do if all those micro components fail? So do we actually abandon the application, or we need to keep going? So resilience is about accepting failure and dealing with what works. Scaling, so microservices, so different services that hopefully are deployed on a cloud-native application and can be optimized and replaced as we go. So the other advantage of Spring Cloud is basically through declarative programmation, like using the annotation. So we can actually leverage all the feature of Spring Boot and also start to implement this microservices pattern, so which constitute of all those elements. So basically, so like what we see here, configuration, service discovery, circuit breaker, all are, I would say, pattern that we can find in a microservice implementation, cloud-native implementation. What I can say is, what I liked with Spring Cloud is like, if you know a bit of Spring Boot, if you know already Spring Boot, so all of them is actually Spring Boot application, REST-aware Spring Boot application. So I'm not going to cover everything because of time, but we can speak about it later. So that's what they look like from the high level. So this is the ecosystem, microservices using, let's say, platform microservices. What I call platform microservices are the microservices that enable the microservices pattern. And we're going to see them a bit more in detail. So that's what Spring Cloud implements. So, and the microservice leverage the microservice platform to communicate amongst each other and scale. So in the microservice architecture, we have interesting feature, which is configuration. So in Spring Cloud, we have a Spring Boot service that's called the Spring Cloud Config Server. So what it is no more than less than a centralized configuration that every microservice can fetch. So basically, so let's say you have you want to configure the port for an application, a microservice A, B, or C. So you can actually centralize all your configuration in a Git repository, and those information will be available on Bootstrap of those microservices. So the config server that we see on top, as I mentioned before, is a Spring Boot application. So that's REST communication. They pull through REST API communication, and the communication with Git is like communication on GitHub or over the network. Service discovery and registry. So that's a picture for microservices, and the way it's done with Spring Cloud is through the Eureka server. So I'm not going to go through that, but what I want to say here is the problem that we want to solve is, so if we have a microservice and we're scaling, so basically that means that we're going to want to have different instances of the services to be able to serve a pool of client requests. So we've got a service that has different instances, but also different IP that are assigned to it. So these microservices have different instances and several IP assigned to it as a client that wants to consume it. So what happens if one fails? So basically the client needs to be aware about the change of IP address, and that's what the service registry is helping with. So basically the service registry in the registry and discovery approach, the service registry is actually a database where the microservice actually exposes its identity, say, okay, I'm here, I started, I want the microservice application to know that I'm here. So basically, if that happens, so if the microservice is started, so that means the microservices B will be able to communicate with, let's say A with B, because B had registered before. So the database holds names of microservices, and those names are matched with IP address, which are dynamically changing. So, like not the DNS, but it's more like at the microservice application level. So, so I said before that the microservice is actually registering itself to the service registry. So when it starts, the service registers itself, yes. So there's a system of heartbeats, so it's not only once. So basically, the microservice checks each time that it renews its registration, so that it won't know that it's alive. And when, for example, it's shut down or it needs to be replaced, there's a team that upgrade the service and need to start and restart it. So basically, the service can unregister itself, and that's it. The microservice application and the developers, the team developing those microservices, would be aware that either the service is not existing anymore, or it's being upgraded, or there's a failure. What else? So this is the implementation of, as I said, it's a Spring Boot application. It's just a matter of adding a annotation. So it's annotation based. So the enable Eureka server is saying that the application is an Eureka server, so service registry. And discovery client is saying that the client is a microservice client that's gonna inform the service registry that is available. Is that okay so far? Am I going too quick? Okay, all right. How much time?
10 minutes. Yeah, a bit over 10 minutes.
Good. All right. So that's my first talk, by the way. All right. Okay. Intercommunication. Yeah, I think that the only thing I wanted to say there is like routing and messaging amongst microservices is important, because when you build a cloud native application, my understanding, and tell me if I'm wrong, I'm happy to hear that, no problem. Yeah, cloud native applications can be applications that have between 50 and 100 microservices, so we need to make sure that the strategy to communicating amongst microservices is reliable. So for routing and messaging, so Spring Cloud offers load balancing via ribbon and open pane, and HTTP requests are handled this way as well. And we can also handle asynchronous messaging using message queues such as Rabbit and Fury. You would know, So REST template, I think some of you might know it. I just wanted to touch on Pane clients. Pane client is a new way of that Spring Cloud introduced in terms of, I think it's Netflix, of introduce separation of concern. So when you used to use REST template, you have to map the URL and define the service ID, include the parameters and everything. We don't want that as business service developers. We want to externalize actually the definition of the microservices per se and focus on the business services. So basically, if you have the client, we describe Pane client with the service ID, which is unique, and then we do the mapping of the microservices, the URL and everything. And to use the microservices within a unit of work, you would actually declare the interface as another wired bit, and you call the service to that interface. So basically, we externalize microservices configuration through a Pane client. Load balancing, I'm going to pass through that.
You got some time.
Yeah? Oh. All right. This was my talk mostly. Like the idea is, it's not so much saying, okay, Spring Cloud is a way to go. It's more like, so given the microservice pattern, so how can I actually leverage the skill that I have as a developer to use Spring Cloud? So what I didn't like with Spring Cloud, I wasn't clear whether actually you could actually implement polyglot microservices. So I don't know if you can, because I'm still looking at it, I don't know if you can actually make a Java microservices implementing Spring Cloud communicate with, I don't know, .NET microservices. I don't know if it's something reasonable to say, but maybe through containerization that would be possible. Yeah, so that's why I'm saying maybe it doesn't cover the full microservice architecture concept, because to my understanding is we want to be in an ecosystem where team can implement their microservices independently of the language or the data source, the data persistence mechanism. But what I like is, yeah, it's polyglot persistence. You can leverage Spring Boot quite easily through declaration using Sanitation. And yeah, it hasn't been too hard apart from the Maven issue that I was facing to get it going. All right. Next step. So this is these are the things that I haven't covered in the lightning talk. So I'd like to invite anyone in the audience to cover it. Maybe. One day I come back to this talk in more depth. But I think there's space for us as a community to explore. You know, like I would wonder what are the approach and what is the lesson learned from migrating from monolith to microservices or containerization of those microservices. I'm really curious about where serverless microservices are going. So these are next steps for us as a community and Lightning Talks, and I'll be happy if someone can also share. That's all. So next we have.
What is it? So, is there any Java 8.
Yeah.
Who in the audience uses Java 9 and above? Alright, you got one hand.
Migrated to Java Talks.
Yeah. So just to repeat, who uses Java 9 or above in production? Alright, just two. So you're good.
Oh yeah. Yeah, you can get in touch with me if you want further question afterwards. I'm happy to chat. Yeah.
I'd just like to point out to everyone that Pat had a full slide deck, as you probably have seen, that he has for tonight's talk. So he's welcome to come back and do this again. But props to him for changing it on the fly and doing some circuit breaking on some of the slides.
I hope I sparked your interest.
So the slides available somewhere? I need to clean a little bit because there's things that are copyright. I need to make sure. I like to.
Yeah, working over, and then I share. Yes.